Now let's solve this 3D problem from chapter 5. So as you can see here, we have a bent rod that is supported by 3 smooth journal bearings, and we have the force F, that is an inclined force here, having a magnitude of 800 newtons. So the question is to find the reactions of the smooth journal bearing. Now here, as you can see, we have the free body diagram of the bent rod. And because we have this rod is supported in more than one location, it means I have more than one smooth journal bearing, I will not have moment reaction. I will just have force reaction. Now, this force reaction, it will be perpendicular to the plane of the rod. For example, for the rod at A, this rod is along the y direction, so I will have reaction in the 2 other perpendicular direction, which are AX and AZ. The rod that is passing through B, which is here, is on the direction of X, so it will have reaction in the 2 other perpendicular direction, which are BY and BZ. And the third rod, which is along the Z-axis, it will have also the other 2 forces that are perpendicular, the other 2 reactions that are perpendicular to the Z-axis, which are CX and CY. Now here, because we are in 3D, we have 6 equations of equilibrium that are summation of forces about x is equal to 0, summation of forces about y is equal to 0, and summation of forces about z is equal to 0. In addition to that, we have summation of moment about x is equal to 0, summation moment about y is equal to 0, and summation moment about z is equal to 0. Now, the first step, because here they gave you the force F as magnitude, which is 800 Newton, so we need to write it in the Cartesian form. So F is equal to a component in x, fxi, plus fyj, plus fz. Okay, and we need now to find fx, fy, and fz. So let's do now the projection. First here, if you can remember, we have f prime. So f prime is like a middle step to do the projection on x and on y. So this is f prime. So to find fx, which is the projection of f about the x-axis, we need to do a projection first to find f prime, then a second projection on the x. So the first projection will be f cosine 60 multiplied by cosine 30. So f cosine 60, I will be projecting here, f prime, this is f prime. And then I multiply by cosine 32 projected on the x. So if we do the calculation, if we replace f by 800 Newton, which is the magnitude of force F, we will get here 346.4 Newton. Fy, we need to project on the y-axis. So first also we need to find f prime, which is f cosine 60. Then we need to multiply it by sine 30, because we need the side that is opposite to the 30 degree, which is here, that is on the parallel to the y-axis. If we do that, we will get here 200 Newton. Fz is just the projection on about the z-axis, which is like this. So it will be equal to minus f sine 60, and it will be equal to minus 692.8 Newton. So if I want to write f in the Cartesian form, I can say that f is equal to 346.4 I plus 200 J minus 692.8 K. Now, let's apply the 6 equations of equilibrium. So we will start by summation of forces about x is equal to 0. So what do I have about x? I will have here ax. I will have also Cx and the x component of force F. So Ax plus Cx plus the x component of force F, which is 346.4 equals to 0. So this is equation number 1. Equation number 2, summation of forces about y is equal to 0. So what do I have about y? I have by plus cy and plus the y component of my force. So by plus cy plus 200 equals to 0. Summation of forces about z is equal to 0. Here I have az plus bz minus 692.8 is equal to 0. Now these are the 3 equations of equilibrium for the forces. We also have 3 equations of equilibrium for the moment. So summation of moment about x is equal to 0. And this is, I did this problem on purpose just to remind you about how to find the moment in 3D of the forces using the right-hand rule. Okay, and if you don't get it, you can go back to the lecture where I put for you the symbols, how to use the right-hand rule. So for summation of moment about x, this is my x-axis. The forces that are touching the x or that are exactly pointing on the x-axis will not have moment about the x. So ax and az will not have moment about x. In addition to that, the force that is parallel to the x-axis will also not have moment about x. Okay, in this case, Cx, for example, will not have moment about the x-axis. So Ax, Az, and Cx will not have moment about the x-axis. So here we have Bz. Let's start by Bz. So I will place my thumb along the positive x, and the rotation of my 4 fingers will point for me the positive rotation. So if I place my thumb here along the positive x, my 4 fingers will rotate like this. It will be opposite to By. Sorry, it will be in the same direction of Bz. So I will have here Bz. And what is the perpendicular distance from Bz to my x-axis is 2. So multiplied by 2. Now let's see if By will have a moment. So By is actually not on the x-axis, it's not touching the x-axis, and it's not parallel to x. So it will make moment, right? But what is the perpendicular distance between By and the x-axis? It is actually 0, because By, it is on the plane where the x-axis is. So just imagine Cy, just compare Cy and By, okay? So Cy will have moment about the x, but By, because it is here, so this 2 meters is 0 meter for By, therefore By will have 0 moment about x. Why? Because the perpendicular distance from By to the x-axis is equal to 0. To understand it better, just compare By with Cy. So if I move By upward, it will have moment. But since By is exactly on the plane where the x-axis is, therefore the perpendicular distance between By and the x-axis is 0. So we have also Cy. So let's put our thumb along the positive x. My rotation, my 4 fingers will give me the positive rotation, and it's giving me opposite rotation to Cy. So I will have here minus Cy, and the perpendicular distance, as I said, is equal to 2, this one. Perpendicular distance between Cy and the x-axis. Okay, and we also have a component of the force F. So my force F, it will have here Fx, Fy, and Fz. Okay, so Fx, it will not have a moment because it's parallel to x. Fy, it is the same case as By. It will have moment, but because, it will have moment because it's not touching the x-axis, it's not parallel to x, but the perpendicular distance between Fy and the x, which is vertical, the vertical distance is equal to 0, so Fy will not make moment about x. The only component that will make moment about x here is Fz. So Fz will have a negative moment because if you put your thumb here, your finger here, the remaining 4 fingers will give you this rotation, which is opposite to Fz. So here I will have minus z component, which is 6, 9, 2.8 times 2, which is the perpendicular distance between Fz, this one, and the x-axis, which is this 2 here. Okay, so this is the first equation. Then we need to do summation of forces about the y-axis. Summation, sorry, of moment about the y-axis. So about the y-axis, let's check what forces will make moment. This is my y-axis. AZ and AX will not make moment because they are touching the y-axis. Fx will not make moment. Fz will not make moment. They are touching the y-axis. Fy will not make moment because it's parallel or passing through the y-axis. By will not make moment, and Cy will not make moment. So you'll still have Bz and Cx. If you apply the right-hand rule, you place your thumb along the positive y, you will get that you have a positive moment for Bz, and the perpendicular distance between them is 1. So I have Bz times 1 and what else? And Cx. So if I place also my thumb along the y-axis, I will see that I have a positive rotation for Cx and the perpendicular distance is 2. So here I have plus Cx times 2 is equal to 0. And finally, we have summation of moment about z is equal to 0. Ax, Az will not have moment because they are touching that z-axis. Fz will not have a moment because it's parallel. What else? We have Fx. So if we place our thumb along the positive y, we will see that we have a negative moment for Fx. And the perpendicular distance between the Fx and the z-axis is equal to 2. So we will have here minus 346.4, which is the x component of my force F, multiplied by 2. Then we have By. So if we place our thumb along the Z, the rotation, my 4 fingers will give me a negative rotation for By. So minus By, and the perpendicular distance is 1 from By till the Z-axis. So I will have here minus By times 1. And we have Cy and Cx. So also Cy will give me negative rotation and the perpendicular distance will be equal to 1.75. Cx will also give me negative rotation. So here I'm basically placing, I will try to draw it for you, but you can please check the previous lecture about this. So I'm placing my big finger or my thumb here along the positive z-axis, and my 4 fingers will give me the positive rotation. So as you can see, this is my positive rotation. It's opposite to Cx and it's opposite to Cy. So that's why Cx and Cy will make negative moment about the z-axis. For Cy, the perpendicular distance between Cy and z is 1.75, and the perpendicular distance between Cx and z will be equal to 2. Okay, so here let's continue this. Okay, so minus Cy times 1.75 and minus Cx times 2 equals to 0. Now, if we do the calculation, you will find the 6 unknown. You will find that Ax is equal to 400 Newton, Az is equal to 800, and By 600, Bz negative 107, Cx 53.6, and Cy 800 Newton. So this is just important. For sure, you will get one problem in the final about 3D. It will not be very complicated, or it will not require too much calculation, but at least you need to know how to find the moment in 3D, what are the equations of equilibrium. You need to draw the free body diagram of your section or of your member. Okay, so review this. This is, I think this is chapter 5. So review it as well as chapter 6, chapter 7, chapter 6, which is about the trusses, chapter 7 about drawing the shear and bending moment diagram, and the final chapter, which is chapter 10, which is about the moment of inertia. Okay, so this is the end of the revision problems. So if you have any questions, you can send me in an email. I will be available to reply to you. Thank you for listening and good luck in your exam. See you on Sunday.